Hello everyone, my name is Moritz Weber and I will give a short introduction to the features in the embedded Monty-Arc deep learning toolchain that I implemented as part of my bachelor thesis. As part of the thesis, we implemented a new dataset handling strategy to allow the use of multiple datasets. In particular, datasets can now be split into smaller parts and serve as extensions to existing datasets. To take the new datasets into account during retraining, we use parts of existing retraining approaches and have adapted them to our purposes. The goal is to have consistent accuracy, less training time, and the ability to react to new dynamic datasets and concept drifts. First of all, we will give a short introduction about two different roles, which are involved in a typical machine learning workflow. The first actor is the data scientist. Their tasks include the capturing, cleaning, and validation of data. As part of our implementation, the data scientist will deploy the base dataset, extension dataset, and any number of other extensions. The other role, the machine learning engineer, will choose the corresponding datasets for the training, set the training configuration, and is able to start the training. Dealing with new and changed data then happens automatically during training. We will get to that in a moment in a technical example. To give you a better understanding of the technical structure, we have modeled an example using a split MNIST dataset. A new concept is artifacts, each of which can contain multiple datasets. In this example, the base artifact contains the test dataset and the first part of the training dataset, which we call the base dataset. In the extension artifact, we can see the second part of the training dataset, which references the base dataset. Artifacts can be installed locally, can be pushed to a Maven registry, and are specified in the network tagging configuration before training. Now, let's switch over to the technical example. All of these steps are typically performed as part of a continuous integration pipeline, but are shown manually for illustrative purposes here. We start with the perspective of the data scientist, who would like to deploy a first training and testing dataset. In our new XML configuration, you can see the specification of both datasets, the main and the testing dataset. Each dataset has a unique identifier and a path to the local file system. In addition, metadata like the testing flag can also be stored here. We will now install the dataset using the model framework by running the install dataset goal. As we can see, the dataset is now installed locally. In the next step, the machine learning engineer picks the installed artifact. The artifact is specified in a tagging language, as you can see here. The machine learning engineer then starts the training. We have speeded up the process a bit. We can now see that the training was successful. Now we have the scenario that the data engineer has new data that should be used for training. Therefore, the data engineer installs the new extension dataset. As it is an extension of the previous dataset, we can reference the base dataset here. In addition, we create a dependency to the base artifact. Then we run the command again to load the dataset into the local registry. And we can see it was successful. We are now back in our training environment, and the machine learning engineer can now specify the new extension dataset in the tagging configuration. Another option is the retraining type, which has to be specified in the network configuration file. In our case, we use the automatic retraining type, which automatically determines the learning rate, but there's also the option to specify a custom optimizer for the retraining. Finally, the machine learning engineer can start the training. The program can now automatically resolve the extension and the base dataset. We can now see that the Email toolchain automatically detected the new extension and that a pre-trained model for the base dataset already exists. The model is reused automatically, which we can see in the logging messages, which state that the pre-trained weights and the last learning rate of the network are loaded. We can now see that the retraining was successful. For the end of the video, we plotted the accuracy over the epochs of the training and can perfectly see that the training of the extension dataset already starts with a high accuracy and is used to fine-tune the result with the new data. I hope I was able to give a good insight into the new functionality. Thanks for watching.